Whenever we want to produce a Carnot cycle, there are a lot of situations which are non-practical. For instance, the isothermal entrance of heat will have, for instance, associated with it that we will be working in a region which is not very practical. So, for instance, we have to introduce Rankine cycle. Rankine cycle deals also with a boiler, a turbine, a condenser, and a pump. Here is that, for instance, if you remember, a Carnot cycle looks something like this. And it was working, for instance, in the region of saturation, which is not very practical. For instance, in the zone of the turbine, we will be dealing with certain droplets or certain amount of liquid that can actually affect the turbine. Also, for instance, with the pump will be also affected if we are working in this limit. So this is not very practical. Instead, we introduce, for instance, the Rankine cycle. Rankine cycle is going to be working with the pump, which is in a liquid phase. And, well, we're going to assume once again the isothermal process in the boiler, but now we're going to get to an overheated state. And in an overheated state, we can actually get more energy from the turbine. Do you see that we can actually get more energy? This line, for instance, is lower than the other line, than the actual line. So we will produce more energy, and we can still be working in this situation. But Rankine cycle is stating, okay, we're going to be working in other states, right? And for instance, it's still going to be an isentropic compression in the pump. It's going to be still a constant temperature, or in this case, we're not going to say temperature, we're going to say pressure. The pressure is going to be constant in the boiler and in the condenser, right? Although you might actually see that in some phases the temperature is remaining constant, and in the turbine is going to be isentropic as well for the ideal Rankine cycle. At the very end, we're interested in the efficiency, which is 1 minus the heat that we're going to output, right, in the condenser over the heat that we're going to introduce in the boiler. This is, for instance, as well lower than 1. So Rankine cycle proposes another change or a change in Carnot cycle, which might actually produce a little bit more work, although its efficiency is lower than Carnot, but has a more practical way of doing this. And for instance, this is ideal, and we're going to discuss later on other deviations of the Rankine cycle.